differential equations, we are jumping back into our 4.7 e-learning assignment, and we're now going back to section 4.4. These are not Cauchy-Euler differential equations. You don't see an x to a power where the power would match the order of a derivative. Rather, this is really going back to what we were doing previously in section 4.3, except now our differential equations can be non-homogeneous. Our right-hand side over here is not zero. So we're going to use a method called undetermined coefficients. Here's what we have to do first, though. We're going to solve the homogeneous differential equation. We assume that y equals e to the mx here. And, when you get that, you'll have m cubed minus 6m squared is equal to 0. This is called our characteristic equation, by the way. And we could factor out an m squared. And I hope you can see that because m squared is here, 0 is what we call a double root. And m minus 6, of course, saying that equal to 0, you would get m equals 6. So really we have what we could call our complementary solution. And that would be e to the 0, which of course is really just going to be a constant, isn't it? The fact that we've got 0 showing up again, remember how we would deal with that. We'd put an x out in front. And then finally we'd have a C3. Here we'd have e to the 6x. What are we really seeing? Well, we've got just some constant. That's, e to the 0x is just a 1. And then this is a 1 also. We've got, call this C2, pardon me, C2x. And then we'd have C3e to the 6x. Now, that's not going to be your final answer. It's going to be part of it. We're going to need that. We're going to use that in just a moment. However, what we are going to do right now is we're going to look for a particular solution. And, I put that chart up in our previous posting on a Google Classroom where you can pull that up. It was our first day of section 4.4. And we can assume that, we've got a right here, like a 3. That's just a constant. You'd say, well, I'm going to assume that we've got an a showing up. But here's the problem. And this is why I really wanted to bring this up. C1 is just like a regular constant, isn't it? And then on top of that, it has shown up yet again. It showed up as a double root. So here we'd have a constant showing up. We're going to have to write that as one more repeat. We're going to have to throw in one more factor of x. So that gets to be so very, very subtle. We have to be so incredibly careful about that. But that's key to being able to work this out. So when you see that, what would appear to be a particular solution, if it's already showing up in your complementary solution, whatever repeats you have to throw in one additional factor of x. So please be careful about that. Then what? We've got the cosine of x. Well, the cosine of x, you could write this as b cosine of x plus c sine of x. Pardon me. And you could have switched the order. You could have said b sine of x plus c cosine of x. But in general, this is what you're going to have. Remember, whenever you have a cosine, you're going to have the other complementary functions, sine. Sine and cosine always come in pairs. So what do we do with this? Well, we're going to say, well, we could get a y prime, take a derivative, we'd get 2ax. What's the derivative of cosine? Well, it's going to be a negative sine. And what's the derivative of sine? Well, it's just going to be a cosine. And then we're going to take a second derivative here. Our second derivative, the derivative of 2ax with respect to x is just going to be a 2a. The derivative of this sine is just going to be a cosine. And the derivative of cosine is going to be a negative sine. Then we're going to do one more derivative. The next derivative of 2a, that just goes away. The derivative of cosine is negative sine, so out comes another negative. This becomes a b sine of x. And what's the derivative of sine? Well, it's just a cosine. So we have this, c times the cosine of x. Well, now we just have to go through the work of finding what these coefficients really are. We've got y triple prime minus 6y double prime, and we're going to set that equal to a 3 minus cosine of x. Well, what was y triple prime? Well, it was b sine x minus c cosine x. And then the second derivative was a 2a minus b cosine of x minus c sine of x. And it's at this point where we're just going to have to do a lot of cleaning up. So we've got our b sine x minus c cosine of x. I'm going to distribute right here and get a minus 12a plus a 6b cosine of x plus a 6c sine of x. And over here we can say, of course, we have a 3 minus the cosine of x. So hopefully you can see that we have actually, on the left-hand side, 3 different types of terms. We've got a term that does not have trig associated with it at all. That's minus 12a. We've got terms with cosine. There are 2 of them. And if I were to just say put a plus here and factor out the cosine from them, I'm going to be left with this. Of course I have a 6b cosine of x minus a c cosine of x, but factor that out, pull the cosine out, that's really what you're going to be left with. And then finally, what you're going to see is you've got 2 terms with sine. And that's going to be a b plus a 6c when I factor that out. So let's just look at this right-hand side in a different light too. I'm also going to put in a 0 sine x. And then we just do coefficient analysis. We're going to say, well, look, minus 12a is going to equal a 3. And if I divide both sides by negative 12, 3 divided by negative 12, well, you'd get a is equal to negative 1/4. So that's all nice. Then what? Well, what you've got to really pay attention to is the coefficient in front of cosine. That's got to equal negative 1. So what we're really saying is 6b minus c must equal negative 1. Likewise, what is in front of sine must equal 0. So we can say b plus 6c must equal 0. Now, of course, right now you can see that we've got a system of equations right here with the 6b minus c equals negative 1. Tell you what, I'm going to take this equation, the first one, and I'm going to multiply by 6. And the reason why I'm doing that, I hope you can see, is that thankfully we're going to be able to cancel out the c's. We're going to be able to get 37b equals -6, and then b will equal -6 over 37. And that, in and of itself, is just wonderful. We're so close to finishing up. Look, you know that b plus 6c is equal to 0. But now I know what b is. b is -6 over 37. So I'm going to add a 6 over 37. I'm going to multiply both sides by 1/6. And that's going to lead me to c being equal to 1 over 37. So here's the nice thing that we just figured out. I'm going to make this a little bit smaller. We assumed earlier that y was equal to ax squared right? We had ax squared plus b cosine of x plus c sine of x for our particular solution. Well, what's that particular solution really going to be? A -1/4 x squared. Your b you just found was a -6 over 37. And your c was 1 over 37. So things are getting better. You've got your particular solution, you've got your complementary solution, and now we can put them together. So I'm going to take this and that and say, in general then, we've got our complementary solution, and we also have, adding to that, our particular solution right here. So it's a little bit longer of a problem. And it was trickier because of the repeat solutions. You know, in that complementary with that C1 right up here, you could see that's really just some constant. And then it was a double root, so we needed a factor of x. And then for our particular solution, we saw even right up here, when you just saw just that 3, we had to throw in one additional factor. So I'm going to close here. We'll have one final video with the last problem.